So maybe we like those rules for fractional exponents. Maybe we like them because, well, we already knew them for whole numbers, and we can use them wherever we have radicals. For example, if I wanted to know what's the cube root of the square root of 8, well, I could try to stick to radicals. I could rewrite this as maybe 2 root 2 and then play with the cube root of the 2 and so on. But what else could I do? Well, I could just write this as this is 8 to the 1/2 to the 1/3, which we know is 8 to the 1/2 times 1/3. Well, I can do either of these first. I could take 8 to the 1/2 to the 1/3, or I could take 8 to the 1/3 to the 1/2, because both of these are going to give me 8 to the 1/2 times 1/3. 1/2 times 1/3 is the same as 1/3 times 1/2. So what could I do here? Well, I like this one because that allows me to take 2 to the 1/2 right off the bat, because 8 to the 1/3 is 2, cube root of 8, and that's just radical 2. Or maybe even I leave it like this if we really want to stick to rational exponents. So since I was given radicals, I'll leave it like that. Both are correct. So that's just an example where we had roots, and we're allowed to convert it to fractional exponents if it seems to make our lives easier.